So the transfer function, impulse response, pole location and stability of various transfer functions we'll see in this session. And the transfer function is given as 1 by s plus 2 whole square. So for this the impulse response will be t into e power of minus 2t into u of t. This is the impulse response of this transfer function, and this will be like this. So this is the time t and this is the output c of t. The impulse response will be like this, and the pole location are s plus 2 whole square. So therefore there are two poles which are located in the minus 2. So at s is equal to minus 2 there are two poles are located which are repeated roots. So even though there is repeated roots in the left hand side, there is no problem of stability, so that the system is stable. And for the second case, 3 by s plus 2 whole square plus 9, so the impulse response will be here e power of minus 2t sine 3t into u of t. So therefore it is e power of minus 2t, exponentially decaying sinusoidal waveform. So exponentially decaying sinusoidal waveform as time t tends to infinity. So this is the waveform of this. This is the waveform of this transfer function 3 by s plus 2 whole square plus 9. And here the roots are complex conjugate. So here the roots are minus 2 plus or minus 3j. So minus 2 is here, plus 3j is here, and minus 3j is here. So the roots will be minus 2 plus or minus 3j one root, minus 2 plus or minus 3j another root. So the roots are complex conjugate and the system is stable only. So because the roots are lying on the left hand side of s plane, that's why the system is stable. And when you see this 1 by s, it's a step response. So therefore the impulse response is like this only. The impulse response will be a into u of t. The roots will be only one root lying at origin. So as and when one non-repeated root is lying at origin, then the system is marginally stable or just stable. So there is no repeated root is available, so hence it is called as marginally stable system. For this, the impulse response is t into u of t, and it is a ramp signal. There are two roots lying at origin. So repeated root is available at origin, the system is unstable. And 1 by s square plus 9, the impulse response is sine 3t into u of t. It's a sinusoidal waveform having oscillations, fixed oscillations. So this is the oscillations, continuous oscillations are there. So the waveform which is having continuous oscillations is a marginally stable system, and the roots are lying at plus or minus 3j, and the system is marginally stable. It's a sine wave. And coming to this 2s by s plus 1 s square plus 1 whole square, so there are complete 4 roots are available. So s square whole square, that means 4 roots are available. And here the impulse response of this one is t into sine t u of t. So as we are having square here, we will get t in front of this, and s square plus 1 square is a sine function. So this is the t into sine t u of t. So exponential sine wave like this. And the roots are here s square plus 1. So s square plus 1 is equal to 0, s square is equal to plus or minus j, repeated roots. So therefore two roots are available at 1j and another two roots are available at minus 1j. So therefore the system is directly, we can say that it is an unstable system because repeated roots are available on the imaginary axis. And here coming to this transfer function 4 by s minus 2, the root is lying at s is equal to 2 and the impulse response of this one is 4 into e power of 2t u of t. That means at magnitude 4 the response is exponentially increasing at from 4. So therefore the root is lying at s is equal to 2. It is nothing but a unbounded output. So definitely we can say this as a unstable system, or from this diagram one root is lying at right hand side of S plane, so therefore the system is directly unstable. So whatever we are having positive sign of exponential term, that will be most probably unstable systems. So impulse response of this one is e power of 2t sine 3t into u of t. So directly we can say that exponentially increasing sine wave with positive sign. So therefore it is an unstable system only. So here this one will be like this. Let us take this is a exponentially increasing sine wave and the roots are lying at minus 2 plus or minus 3j. So the poles are lying at right side of the S plane, so therefore the system is unstable. So this is how we can express the stability of a systems for various type of systems as an examples.